This scenario is on using Excel matrix functions. We're going to use Excel matrix operations to solve systems and also to solve systems of 3 and 4 equations. We'll be able to solve multiple entries and program Excel to solve matrix operations. So Excel does do matrix operations. Let's see how that works. If there is one variable, Excel uses 2. If there are 2 equations or more, Excel uses solver. The problem there was that it was pretty hard to write that equation, to format that correctly. Matrices have been around for a long time. Excel is like one huge matrix, so it is ideally suited to solving matrix operations. Excel has a pretty useful function with matrices. You don't need to know anything more about matrices than you already do. That is, you know how to enter 2 equations into your Casio calculator. You can also think of Excel sheet as being one huge matrix. Each cell has row and column addresses. A matrix is symbolized with brackets around it. It's an arrangement of numbers in rows and columns where each address is unique for the values that it contains. The 2 matrix operations that we will use in Excel are matrix multiplication and matrix inverse. The other part of solving with Excel involves the same mathematics you used in this equation. 3x is 12. So what did you do? You solved the equation by using the inverse of multiplication to get x alone. So x is 12 times 1/3. So if they have a matrix operation a times xy, we can get the xy all alone by dividing both sides by a, or taking the inverse of a. And that's exactly what we're going to do in our, in our operation here. I'm going to make that a superscript. All right. So let's get started. First thing we're going to do, write our name in the top, and then we're going to scroll through our problem. Okay, so we have the coefficient matrix and the constant matrix. I'm going to say it's not that equation. Let's use this one down here, example 5. So the coefficient matrix in this case is -8 and -2. And the coefficient matrix for the second row is, -6 and -10. Our answer matrix, the constant matrix, is 84. And 148. So those are our 2 matrices. Okay. So here's how we're going to do it. It says the first thing you do is you fill in the matrices. So we've got -8, -2, and 84. And we've got -6 and -10 and 148. What you need to do is to highlight your 2 boxes here for x, your 2 cells for x and y variables. Then type equals MMULT, because we're going to use matrix multiplication. What happened here? Matrix multiplication of our first array is I'm sorry, we're going to do I'm going to pull this down so that we can see what we're doing here. Our first matrix, we're going to do the inverse, M inverse, of our coefficient matrix. of our coefficient matrix. And our second array is going to be our constant. Oops. I thought I clicked on that. And our second array is going to be our constant matrix. So you can see I've got the inverse of the first one times the multiplied by the second one. And when I press, oops, I got to do it again. Equals matrix, come on now. Equals matrix multiplication, parentheses, pull down the fx. Our first array is the inverse of, matrix inverse of our coefficients. Our second matrix is our constant terms. And this is the part that I forgot to tell you. You have to press Control, Shift, and Enter, not click OK. Did I only have one cell highlighted? Let's try this again. Okay, so highlight the two cells. Type equals matrix multiplication, parentheses. Click the FX button. The first one is going to be the inverse of the constant terms. And the second one is going, I'm sorry, of the coefficients. The second one is going to be the constant terms. Press Control, Shift, and Enter. And it tells us both values. If you don't press Control, Shift, Enter, you have to do it again so that you get both values filled in when you highlight both of them, -8 and -10. Okay, next. This is a 3x3 matrix, which is a little bit tougher. A total of 350 people attended the movie. The next one is example 5, and we're going to use 3 equations to solve this problem. We have the number of adults plus the number of children plus the number of seniors is 350 people. It tells us that there were twice as many adults as children. So for every 1 adult, there were -2 children if you want them to be equal to 0. I'll show you the math for that. Okay, remember that twice as many adults as children, so this is what our variable is. Children is twice as many, there were twice as many adults, so 2 children, twice as many adults as children. And so if we get all of these on the same side, adults is 2 times the number of children. So if we get the -2 on the other, or if we get the 2 on the other side, it's a minus 2 is 0. And same thing for the last one, 4 times as many seniors as children. So we have seniors is 4 times the number of children. Put that on the other side, and we have -4. So A minus 2C is the second equation, and A minus 2C, and the third equation is -4 children is 1 senior. Now when we do our variables, matrix multiplication, our first is M inverse, parentheses, get our 3x3 matrix here, close parentheses. Our second one is our coefficient matrix, and when we press Control Shift Enter, it tells us our variables are 100, 50, and 200. Now you can use 3 equations for your problems also. Let's look at this next one. We have 1x, 2y, negative 3z, 4w add up to 12. 2x, 2y, negative 2z, 3w add up to 10. 0x, 1y, 1z, 0w add up to negative 1, and 1x, negative 1y, 1z, negative 2w adds up to negative 4. You can see how the more variables you have, the operation doesn't change any. Equals matrix multiplication of our coefficient matrix. Oops, I'm sorry. The inverse of our coefficient matrix, M inverse of our coefficient matrix, by our constant matrix. Oops. Control Shift Enter, and we get 1, 0, negative 1, and 2. And that's how you do this problem.